In this lecture, what we're going to learn is the basic of transformer. Right? So let me write it down. Transformer. Here. Transformer. Alright. So the problem is that no, there is no problem. Yes, there is a problem. The problem is that in India, the power supply we generally get is 230 volt, right? 230 volt. The general power supply what we get in the household. In this 200 power volt power supply, what we used to get that we can see if we hover over the room, you know that that we have a different point for the fridge, different point for the geyser, different point for the normal usage, different point for the microwave and all the stuff, right? So generally, what is the voltage requirement for any microwave is generally approximately like 220 volt, right? Sorry, 2200 volt. And the basic requirement for one iPad to charge is the approximately 10 volt, right? Now the point is that when we are connecting in the same point one microwave which has the requirement of 2200 volt, 2200 volt, and in the same point when we are connecting another iPad which has a requirement of only 10 volt, so how can these two devices work in the same power supply? That is the point, right? 230 volt supply you have and you want like 2200 volt out of it. So how can you do that? How can you increase the voltage in our household, or how can you decrease the voltage a lot in our household usage? So that is the main question of this point of this class, and that is the main purpose of this class, to understand the basic of the transformer and working principle of the transformer, how transformer basically works. What is the principle, right? What is the principle of the step up and step down transformer? Step up and step down. By the name you have already guessed it. The step up transformer has the property it can step up the voltage, whereas the step down transformer can decrease the voltage to our desired voltage, right? So how can we do that, or how this machine performs basically? So this is based on the principle of mutual inductance, what you have learned in the previous class, and I have discussed that when there is an external circuit, and this coil is basically carrying current. For example, this is an AC source. You can see this is AC source, and let's say this is 230 volt. Okay, AC source. So when this is a 230 volt AC source, this current, there is a current flowing like in this way. So when there is a current, so this current will now generate a magnetic field, right? So this will generate a magnetic field. So before we understand this structure, let me draw one more diagram so that you can understand this one. Let's say, for example, this one is a coil, this one is a coil, and this one is a supply. Okay, and now we have drawn another coil. Let's say, for example, let's say red, and we are drawing another coil, and only couple of turns are there. So, and this is in a point where we have plugged in one, let's say, mobile phone. Okay, so this is a mobile phone we have plugged in from here, and we are charging the mobile phone. I know that there is no charger, they work from the side, but still it looks like a mobile phone, right? Yeah. So the point is that when there is a current in the external circuit in this primary coil, then that will generate a magnetic field, right? This will generate a magnetic field, and this magnetic field basically it will be start from the north pole and end at the south pole, and few of the fields will go through the secondary coil. Okay, this will be in the direction of the current, magnetic field, and when there will be a magnetic field through the secondary coil will experience a magnetic flux, that is rate of change of magnetic flux, and from that particular point, the rate of change of magnetic flux, we know that there will be a current in the external circuit, and this mobile charge begin to glow and it will start charging itself, right? So there is no current in the secondary coil, but still this mobile will get its charge. So for example, like in the recent days you have seen that wireless charger. So these are wireless charger charger, this is the technology behind the wireless charger. They do not have any direct connection with the external circuit. Now you'll say that, so this is the this is the charger, this is connected with the mobile, but they have placed all this loop, the secondary loop, inside of the mobile, and directly they can, when they are placing this mobile close to this charger, so whenever they are placing the phone over the charger, this phone started charging, because the distance between the charger and the phone is not that very high. Even you are sitting over the bed, sitting on the bed, and then charger is nearby, then phone can charge, but the amount of time it will take longer than when you bring the phone over the charger. All right, so that is the basic idea of the transformer. Whenever we can take one coil close to one coil where there is a current and the current is changing, so the secondary coil will experience a magnetic flux, and so in the secondary coil there will be flow of current. All right, so this is the point. So now in the transformer, why we have introduced this on this blue that material, you can say that. So basically what we want is that more of the magnetic field lines, or the magnetic field density or magnetic flux, in the first case, the maximum of the magnetic flux, they are getting wasted, right? So that is the problem when we are bringing two primary and secondary coil close to each other. So in order to prevent that, what we have done here, we have introduced one square, or in other words, in the actual transformer, we will be able to see that there are lots of tiny plates. They are basically placed one by one, and they are making one kind of this kind of structure they will make. Okay, so there are lots of tiny plates. They are embedded together, and they are made up of ferromagnetic substances. Why ferromagnetic substances? We know that in a ferromagnetic substance basically attract magnetic field lines whenever there is a ferromagnetic substance. For example, this is a ferromagnetic substance, soft iron core we are talking about. So when there is a magnetic field lines that will try to penetrate this ferromagnetic substance, then now ferromagnetic substance, what that will do, it will basically attract all the magnetic field lines. It will basically attract close to its center, and the density of the magnetic field lines will increase inside of the ferromagnetic substances, right? So we know that. The ferromagnetic substance basically attract the magnetic field lines, and the density of the magnetic field lines will increase basically, because they are also offering the tiny dipoles towards the magnetic field lines. That's why the magnetic field lines will increase. So that's why we use the soft iron core between these two primary between this primary coil and the secondary coil. Now what will happen is that whenever we will be able to see there is a current in the external circuit, now this current when the current will flow, then the magnetic field lines will generate, and these magnetic field lines will go in this direction, and it will come through the secondary coil, and the secondary coil will experience a change in magnetic flux, and when the secondary coil will change in magnetic flux will experience, then this bulb will begin to glow. If there is a loop, right, and there is a current, and there is a changing magnetic flux. If there's a loop and there's a changing magnetic flux, we can see, then this loop there will be induced current, and this will be induced EMF first, and this induced EMF is basically epsilon is equal to minus d phi dt, but there will be a constant, and that constant will depend on the characteristics of this wire, or the conducting wire is made of, and all that stuff. All right, so we are not focusing on that right now. So our idea is that whenever there is a change in flux, there will be an EMF, right? So in order to solve the problem of losing the magnetic field lines, we have introduced the ferromagnetic substance, and this ferromagnetic substance basically attract magnetic field lines toward itself, or the density of the magnetic field lines will be greater inside of the ferromagnetic substances. So that's why we have introduced a ferromagnetic kind of a coil. It's not a coil, it's ferromagnetic core, where all these coil are turned around in one arm, and around another arm there are the coil, they are turned around. So basically here from the diagram, as you can see, we can name is this one is the primary coil. So primary coil, as you can see, this is the primary coil, and number of turns in the primary coil, let's say n is the number of turns. So in the primary coil we are naming that is np, which indicates the number of turns in the primary coil. So in the secondary coil, as you can see, this is called secondary coil, so we are naming it secondary, secondary coil, and the number of turns in the secondary coil, let's say for example n S, which is indicate the number of turns in the secondary coil. Now as you can see clearly that n is greater than np, right? And in each coil there is the induced EMF is d phi dt, right? D phi dt, or in other words di dt, the amount of current which is passing through. Now what would be the voltage in the primary circuit? The voltage will be definitely the total number of turns, that is primary coil np, and the number of the total number of turns obviously into the induced EMF for the each coil, right? Induced EMF for each turn. So we are writing epsilon. Okay, so we believe that all these epsilons are equal because the radius of these two arms, that arm A and arm B, are equal. So all these turns, they are equal. If that is equal, then V equal to NP epsilon, that is V primary, we would say that. And what would be the voltage across here, or V secondary? V secondary will be that NS into epsilon, right? So as you can see, this is clear. So this is the voltage in the primary and the secondary. For example, we are writing this equation: Vp is equal to Np into epsilon, that is equation number 1, and Vs is equal to Ns into epsilon, this is equation number 2. Now if we divide these two equations, then Vp by Vs equal to Np by Ns. Now if we want to find the value of the secondary voltage, for example Vs here, then that will be that Ns Np into Vp. Now from the diagram it is clearly, we can see that the secondary coil has less number of turns. For example, let's say the primary coil has 100 turns, right? And the secondary coil in this case, let's say, has 10 turns. Now what would be the secondary voltage if we apply, let's say, 230 volt in the primary coil, right? So secondary voltage would be Vs is equal to Ns. We can see that Ns, that is 10, and Np, that is, which is 100. So basically Vp is equal to 200, that is primary voltage 230, and 23 volt. You can see that we have clearly just decreased the voltage in the secondary coil, right? So we have decreased the voltage in the secondary coil. In the same way, following the same way, if you just carefully make this turn, then you can get a specific voltage, or you can get a specific range of voltage whenever you're applying any AC circuit in the AC voltage in the primary coil. So this is the idea of step down transformer. So if you want to increase the voltage in the primary coil, in the secondary coil, then what you will do? Just very simple, the number of turns in the secondary coil should be greater than number of turns in the primary coil, and you are good to go. You can increase the voltage. But wait, is that possible? Like, voltage when we are increasing, do you think that we are violating the very core idea, the energy principle, right? The principle of conservation of energy, which is basically telling us that we cannot get more energy out of nothing, right? Whenever we are getting any energy, definitely some energy is getting used for making that energy. But now if we are talking about the step up transformer, and you have, let's say for example, 10 volt in the primary circuit, and you are getting 1000 volt, like 10,000 volt in the external circuit, because you have made a lot of turn. And is that possible? Do you think that is possible without losing any energy, or is that violating the energy principle? Just think for like one day and then come back to next class, and I'm going to answer this one in the very next class. All right.